I'm Rafael Ottmann. I work for ASML. I'm a software architect. I've been programming with C, C++ since 2001. For C, C++ a little bit later, maybe 2004, 2005. And for this lightning talk, I'm going to share a little bit about testing, some stories, how we decouple production code from test code, or better, vice versa. Thank you. How we remove test and simulation code from our production code, mainly in our legacy software code. Let's give a little bit of context. Imagine we had to test our component in green there, our system under test. And by testing here, let's give a definition. We're not talking about unit testing. We're talking more at the integration testing for the component. What is a component here? In this context, component is a container. Container having different executables, sometimes one executable, sometimes more than one executable. Libraries, share objects, mainly in Linux, and configuration files. And obviously, this container has a responsibility, it's providing some services. So in this case, I have one client, could have multiple clients, does not matter. And we want to test whether those services, the contract is being fulfilled correctly. Where do we test this? We don't test in a real machine. ASML machines are very expensive. So we have to test in a simulated environment. And we want to test as much as possible the real code, the real path. And that was the issue that we were having for our legacy drivers. So we start testing against our interfaces. But what we used to do, we used to extend our production code with test data, test simulation, test state. So, and we start mixing up testing with production, and worst of all, as you can see there in the yellow line, sometimes because of the simulation, the state I put it there, I short-circuit my call stack. I don't go all the way down, and I'm missing coverage for some of our units. And sometimes very important units, important logic is down there. Logic that interface with a mechatronics device, for instance, that could be simulating bad weather condition, like a very rare and hard to simulate fault on the robot, for instance, that I want to see how my recovery of my driver works, right? Because we want to fail safe, obviously, but how our recovery is done with diagnostics, our error logging, and we were missing that information because our simulation strategy was not good enough. So the goal was to have as much as possible testing, really verifying my entire call stack as it was done in a real machine. So two patterns we apply. I'm going to share two of the most common patterns we have applied. One is, move the test code, simulation code out of the production code. So I don't want to see any yellow in my green. So move that to an intercept pattern. Could be a runtime intercept or a deploy time intercept. If I have a robot there, I could write a simulator for that robot. Have a different teams working in production code and test code. The test team is able to write a simulator based on the API specification. Sometimes that simulator is quite simple. Sometimes it gets more complicated. We need to simulate trajectory points, timing, state. So we need to interface with mechatronics engineers. So that's where things get more complex. Obviously can be done. And for my component, my dock, which is dependent on component, is basically a test double replacement that we did there. We can do there. And that's what the goal was, to have completely separation of concern between test and production code. Another pattern that is an extension of this one that we commonly use as well is when we do want to test the interaction between your suit and your dock. right? So it's more integration between two components. You want to see how that interface between them are, the protocol between them is being, we were complying, I guess. So we put a man in the middle there, which, yes, intercept all the packets that we're sending between them, but this recording allow us to record the data, and even hint different data, change the data that is passed back and forth to simulate some other bad weather conditions as well. Yeah, that's what I had.